Okay, another distribution in the row is the hypergeometric probability distribution. So hypergeometric probability distribution is another type of discrete probability distribution. So more or less hypergeometric probability distribution is more similar to binomial distribution. But once again, in binomial distribution, as I already discussed, that the trial will be independent. But in hypergeometric, the trial will be dependent. There will be some dependency on each dependent variable. There will be some dependency of probabilities on one another. For example, the dependent and independent, I just want to give you another example that further to clarify the concept of dependent and independent. For example, if we have a box, we have 3 balls in that box. One is black, one is yellow, and one is red. If I take one ball from it, the probability of any one ball, maybe it will be black, maybe it will be white, or it will be yellow, the probability will be 1 by 3. If I put it back in the box, then this trial is with replacement trial, and in with replacement trial, the trial are independent. But if I put this ball outside and then I want to calculate the probability for another ball, so now in the box we have only 2 balls. The probability of the next ball which I am going to take out from the box will be 1 by 2. So the first ball probability was 1 by 3. The second ball probability is 1 by 2, and the third ball probability is certain, it will be 1. So now in this case, the probabilities of each trial are depending one another. If the first ball is a red ball, the probability of red ball is 1 by 3. The probability of the second ball will be 1 by 2. But if this is not the scenario, then that will be the scenario of with replacement. And with replacement, for example, if I took a ball, the probability is 1 by 3, I will put it back. And then again randomly I will choose another ball. So in this case, the probabilities are all independent. All the probabilities will be same because we repeating it and we put the ball back into the box. So in hypergeometric distribution, which is similar to probability binomial distribution, but in hypergeometric distribution, these are the key differences. The trial are not independent. It means the trial will be dependent on one another. The first probability will be depending on the second probability. This third probability will be depending on the first and second probability. Probability of success change from trial to trial. So that is why if the probabilities are depending on one another, just like I mentioned the example of the box, the first probability ball taking the first probability of the first ball taking 1 by 3. If we put it back in then the probability will not be changed. But if we not put it back in the box, then the probability will be changed, and the probability of success change from trial to trial. So this is a very simple difference between binomial and hypergeometric distribution. More or less they are behaving same. If you calculate the values of hypergeometric, if you calculate mean variances of hypergeometric and binomial, the values will not be too much change from one another. But you need to understand that in the hypergeometric distribution, the trial are not independent, but the trial will be depending on one another. Consider taking a sample from a population and testing each member of a sample for defect. Do this sampling without replacement. So in this case, when you using without replacement, so once again, I am repeating my example again. Without replacement means you not putting back into the box. When you not putting back, for example, in your class, if I want to select one president, one secretary. So if I choose one person in your class as a president, that person will not be counted again in the selection process, because when we choose that person as a president, then we will not put it back. That same person will not be a president, and at the same time she will not be a secretary. So that is why we will take him or her out from the class, and then we will start selection for the secretary. So this is called without replacement. We will not replace in the box example, we will not replace the ball in the box. In the class example, we will not replace, we will not put the person back, we will not enter the person back into the class. So use hypergeometric distribution if experiment is binomial. But samplings, okay, this is another identification. If you are confused that what should we need to do, we need to use binomial distribution or we need to use hypergeometric probability distribution. So this is another indicator. If the sampling is without replacement, use hypergeometric distribution if experiment is binomial, but sampling is without replacement from a finite population, where small n mean this is population n and this is sample n. When you divide sample n, sample size with the population size, and if it is more than 0.05, then you need to use hypergeometric distribution. So these are some indicators which show you that if the trial are not fixed, if the success change from trial to trial, and if the experiment is dependent, not independent. If the trial are not dependent, if the trial are not independent, then in that case we will use hypergeometric distribution. Similarly to the binomial distribution, hyper probability distribution have also 4 properties. Number of trial will be fixed, just like in binomial distribution. Each trial has only 2 possible outcomes, success and failure. So once again, these 2 properties are similar to the binomial distribution, but the other 2 properties are not same. The other 2 properties are totally changed from the binomial distribution. In binomial distribution, trial are independent, but in hypergeometric distribution, trial are dependent. Probability of success in the binomial will not be changed. In the whole process, in the whole game, probability of success will be same. For example, if you throw a coin, probability of head will always be 1/2. It will not be changed. Probability of success will be, but in the hypergeometric, it will be changed from trial to trial. So that is why, with due to these 2 different properties, you need to identify hypergeometric probability distribution, and then you need to use this probability distribution function, where K is the number of unit of one kind classified as success. Just like we use P for classification for success in binomial, we will use K. X represents the number of variables, n minus K, which represent another classified as failure. So if K is success, n minus K will be considered as a failure, and n minus X is n the sample size minus the random variable, and this term is the same, where Px probability of X success in n trial. So the most important thing you need to remember that the first 2 properties are same as binomial distribution, but in hypergeometric distribution, the trial will be without replacement, but in binomial the trial will be with replacement. In binomial the trial will be independent. In hypergeometric the trial will be dependent, and the number of trial will be same in binomial, and the number of trial will be changed from trial to trial in the hypergeometric distribution. I'm just going to show you a very simple example. A large store places its last 15 clock radios in a clearance sale. They have 15 clock radios and they put it in the sale, unknown to anyone. Now, among those 15 clock radios, 5 radios are defective, but nobody knows. Only the owner of the shop knows that there are 5 defective. The customer knows nothing. If a customer tests 3 different clock radios selected at random, for example, if a customer wants to buy 3 clock radios, and if he choose randomly any 3 from those 15, now the question is, what is probability of X number of defective radio in a sample? So now the first property, that there are 2 possible outcomes. The radio will be effective or the radio will be defective. The radio will be working or the radio will not be working. If a customer tests 3 different clock radios selected at random, what is the probability number of defective radio in the sample? So now this is hypergeometric. Why? Because the trial is without replacement. Why without replacement? Because when she choose one radio from those 15, she will not put it back, but he randomly select and he take it. He will not count. For example, when he take one radio, the remaining radios are 15. So now she will take another radio. When she take another radio, the remaining radios will be 13. When she take another radio, the remaining radio will be 13. So this trial is without replacement. She not put in back while selecting a radio. So this is the identification that this is not a binomial distribution. So from this specific indicator, we just decide that we will use hypergeometric probability distribution. So we have 5 defective radios. We will denote defective with K and the remaining n minus K. Total we have 5 plus 10 n. So this is the total, and she want to buy 3 n. So the sample which he select is 3. So now they want to construct probability distribution function for these radios. So now there is a chance that among those 3 radios there will be all working. So in that case, X represent defective radios. When it's all working, that means there is no defective radio. So the K is 5 radio, 0, X is 0, it means no defective, N minus K is 10, and 3 because N is 3, 3 minus 0 divided by NCN, 15C3. So this will be the answer. If there is only one defective radio, so this will be the probability. 5, 1, K is 5, 1, 10, N minus K is 10. Now N is 3 minus 1. So 3 minus 1 is 2, 15C3. So this will be the probability. If there are 2 defective, maybe there is a chance that all 3 are defective. There is a chance that 2 are defective. Maybe there is a chance that only 1 is defective. Maybe there is a chance that no one defective. So in this way, we will calculate all these probabilities. So if all 3 are defective, all 3 which they buy from the store, because the owner only know that there are 5 defective radios. So if all 3 are defective, 5C3, 10, N minus K is 10, others C, 0, why 0? Because N minus X, so 3 minus 3, 0, 15C3, so 5 by 4, 5, 5. So this will be the probability. There is another example. In this question, they are asking you, they not even show you that use binomial or use hypergeometric, but you will use your logical intuition, you will use the properties which I already discussed in great detail. Then when you will be able to use hypergeometric distribution, and when you will be using binomial distribution. So when the trial are without replacement, in without replacement trial you need to use hypergeometric. If the trial are with replacement, in with replacement the trial are independent. In without replacement the trial are dependent. So when the trial are independent, in that case you need to use binomial. When the trial are without replacement, it means the probabilities of one element depending on another. So this is a without replacement. We not put it back. In that case we need to use hypergeometric. So for selection without replacement, we will use dependent trial concept. Therefore, we will use hypergeometric distribution. We have 7 ball are drawn from a bag containing 5 white, 4 maroon, 6 red and 5 orange ball. So how many total? 5 plus 4, 9, 9 plus 6, 15, 15 plus 5, 20. So our N is 20. And how many balls they drawn? So N is equal to 7. And how many? Because they are asking you, what is the probability distribution of the number of white balls? So how many white balls you have? 5. So K is equal to 5. And the other remaining N minus K. So N is 20. 20 minus 5 is 15. And small n is 7. So because the trial is without replacement means the probabilities are depending on one another. So in this case, we will use the concept of hypergeometric probability distribution. And we know the hypergeometric distribution probability distribution function is Kx n minus k n minus x divided by capital NCn. So we will put, because how many white ball you have? We have 5 white ball, and x will be start from 0, 1, 2, 3, 4, 5, because 7 ball are drawn from a bag containing 5 white, 4 maroon, 6 red and 5 orange ball. What is the probability distribution of the number? Because in those 7 balls there is a chance that there will be no white ball, because we have only white ball. Maybe in those 7 balls 4 let's suppose are maroon and 3 red, or let's suppose 6 red and 1 orange, or 5 orange, 1 red. So a lot of combination exists. But in this case, how we will calculate when x is equal to 0? 0 means when there is no white ball. So we know k is 5, 5, 0, 15, n minus k is 15. Now n is 7. So 7 minus 0 divided by 20, C7. So in this case, this will be the probability. Similarly, if there is only one white ball among those 7, so 5C1, 15C6, 15C6 for how? 7 minus 1. Okay, and 5 will not be changed. So in this case, this will be the probability. If there are only 2 white ball, so k is equal to 5, x is 2, 15 and 7 minus 2 will be 5. 20 by 7. So at this way we will calculate these probabilities. Now they are asking you find mean and variance in each case. So you people know that the mean in probability distribution is summation x into px. So x, this into this into this, 2 into this, 3 into this. So at this way summation x into px, so this will be the mean 1.78. Variance of x, we can write it ex square. So how we will calculate ex square? Ex square is equal to x square into px, because ex is summation x into px. So if I write 2 at this place, so it will be summation x square into px. That is why this is 1. So that is why at this place it is 1. So summation ex square will be summation x square into px. So 4.095 minus 1.78 whole square. So our variance will be 0.920. This is the case of hypergeometric distribution when the trial are without replacement, because the trial are depending on one another. The probabilities are depending on one another. Now in order to solve with replacement, and with replacement the trial will be independent. The success probability will not be changed. So when the success probability is not changed, and when the trial are independent, and when the trial are with replacement, then in that case we need to use binomial distribution. So for with replacement the trial will be independent, therefore we will use binomial distribution. N is 7 bar odd one, so n will be 7. Probability of white, so how many white we have? 5 out of 20. So 1 over 4 is the probability of success. Failure, if among in 7, if it is not white ball, so 1 minus probability of white ball, 1 minus 1 over 4 is equal to 3 by 4. And you people know very well, because in my previous lecture I already discussed in great detail binomial distribution. The probability distribution function of binomial is nx, p power x, q power n minus x. So now we will construct the probabilities. P is equal to 0 when there is 0 white ball, so 7 C0 into 1 over 4 probability of white ball power 0, because there is no 0, there is 0 white ball, 3 by 4 power 7 minus 0, 7. So this will be the probability. If there is only 1 white ball, so 7C1, 1 over 4 power 1, 3 by 4 power 7 minus 1 now, because x is equal to 1 now. So 0.311, and in this way we will calculate all these probabilities. In the next step they are asking to calculate mean and variance. So x into px, because ex is equal to summation x into px. So in the next step 0 will be multiplying with this, 1 will be multiplying with 0.311, 2 will be multiplying with 0.311. So when we add all this column, that is why we will write it summation x into px. So the mean will be 1.74. So the mean of binomial and the mean of hypergeometric will be same. If there is a minute, maybe there will be a minute differences, but most likely it will be more similar with the mean of hypergeometric. Similarly, we will calculate variance of x. The formula of variance is summation x square minus mean square. So you people know that ex square is summation x square into px. Okay, so when we add this, it will give us summation x square into px. When you put this and when you take the variance of 1.74, so your variance will be 1.33. So in this way you will calculate the mean and variance of the binomial and hypergeometric distribution. So I hope from this example you understand the main concept of binomial distribution and the hypergeometric distribution. So there are two properties which are different from hypergeometrics. In binomial the trial will be fixed. In binomial the trial will be changed from trial to trial. In hypergeometric, in binomial the trial will be with replacement. In hypergeometric it will be without replacement. In hypergeometric it will be without replacement. In binomial it will be with replacement. In binomial the trial will be independent. In hypergeometric it will be dependent. Okay, just like I have already discussed the mean and variance formulation for the binomial distribution. Hypergeometric distribution have their own formulation. So if you people know these things from its specific data. You not need to construct the whole, just like in the previous example, I construct the probability distribution, and then from the probability distribution, we calculate mean, just like Ex is equal to summation x into Px. So first we need to calculate this. Similarly, for variance of x, which is Ex square minus Ex whole square, which is a little bit difficult in order to calculate. But if you people know this formulation, it will be very easy to solve. It will be very easy to calculate mean and variance of specific question. For example, in the previous slides, we have already solved this. 7 ball are drawn from a bag containing 5 white, 4 maroon, 6 red and 5 orange ball. What is the probability distribution for the number of white ball? If the selection considered without replacement, find mean. So mean the selection is without replacement, so it's a binomial distribution. So the most important thing you need to calculate, because white ball, we have white which are 5, which is equal to k, and n minus k, which is 15, which are others ball. Okay, and the total are 20, which is n. And how many ball they are selecting? N is equal to 7. So we know all these from this question. So now you can easily calculate by using this formula. N is 7 into k. So k is 5 white ball, because they are asking what is the probability distribution of the number of white ball. So white ball are the success, which denote with k, and not success means failure is n minus k, which is 15. So 5, n is 20. So 1.74 or 1.75, which is very near. This is round number. So the mean of this and the mean in the previous will be same. So you can also calculate mean with this. Variance formula is n minus n. So we know capital N is 20 minus 7, 20 minus 1 into n is 7 into k is 5 by 20, 1 minus 5 by 7. Variance of x 13 by 19 into 35 by 20 into 2 by 7. So at this way you can easily calculate the mean, variance and standard deviation of this hypergeometric distribution. So I hope now you understand binomial and hypergeometric distribution, why hypergeometric distribution is different from binomial. So you not need to be confused. If I give you some specific example in exam, you need to understand these two main different properties of binomial and hypergeometric distribution. Thank you.